This is the Algebra 2, Chapter 5, Part 2 review. For the first problem, it's multiple choice, and it's asking you which of the following is not a possible root. So that's the important part. This possible root thing is definitely what you need to be focused on. Whenever you see possible root, you should be thinking about your factors of your constant and the factors of your lead coefficient. Those are the things you need to find. So remember, your constant is the thing at the very back with no x. Your lead coefficient is the thing at the very front, which is in front of your variable with your degree on it, or the highest exponent. So my factors of my constant, if my constant, again, is 4, my factors are plus or minus 1, plus or minus 2, and plus or minus 4. My lead coefficient is 10, so my factors are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So now, in order to determine the possible roots, what we have to do is we have to do a little bit of division here. You're going to divide anything on the top from the constant by any of the factors on the bottom from the lead coefficient. So let's start with a pattern. We're going to take each of our constant factors, and we're going to divide them by everything on the bottom. So 1 divided by 1 is plus or minus 1. 1 divided by 2 is plus or minus 1 divided by 2. 1 divided by 5, plus or minus 1 divided by 5. 1 divided by 10, plus or minus 1 divided by 10. Now, since I've divided 1 by all of those things, I'm going to move on to 2. So now I take 2 divided by 1, plus or minus 2. Say 2 divided by 2. That's plus or minus 1, but we already have that listed, so we do not have to list it again. 2 divided by 5, plus or minus 2 divided by 5. I have 2 divided by 10, which, if I reduce it, is plus or minus 1 over 5, which I already have, so I don't have to list it again. And then I'm going to move on to 4. 4 divided by 1 is plus or minus 4. 4 divided by 2 is plus or minus 2, but we already have that. 4 divided by 5 I don't have yet. And my last one, 4 divided by 10, if I reduce that fraction, I get plus or minus 2/5, which I already have. So these are my possible roots for this problem. Now, because this is multiple choice, it says which one is not a possible root. Well, is negative 4/5 a possible root? Yes, I see it right here, negative 4/5. Is negative 2/3 a possible root? No, because look, I don't have a 3 in my denominator. That's not possible to get B. So I think B is my answer, but I should probably check the others just to be safe. Negative 1 over 10, yep, I have that right here. And 1/2, yep, I have that right here. So my answer is B. B is not possible. I do not have a 3 in the denominator. All right, these next two problems are asking me to do the same thing. I'm listing all of my possible roots. In both of these problems, list all possible roots. So each of these, I'm following that same process. I'm going to identify what my factors of my constant are and factors of my lead coefficient. So in this example, my constant is 25, so my factors are plus or minus 1, plus or minus 5, and plus or minus 25. And my lead coefficient is 5, which means my factors are plus or minus 1 and plus or minus 5. So now when I do all the division, I'm going to do 1 divided by 1, 1 divided by 5. 5 divided by 1, 5 divided by 5. 25 divided by 1, 25 divided by 5. And when I do that, if I get the same number twice, I do not have to write it twice. So your answers you should get are plus or minus 1, plus or minus 1/5. Plus or minus 5, and then 5 divided by 5 is 1 again, so I don't have to write that again. but then plus or minus 25, because 25 divided by 1. 25 divided by 5 is 5, which I already have. So that is the complete list of my possible roots. When I move on to number 3, same thing again. I have to get the factors of my constant over the factors of my lead coefficient. My constant is 6. My lead coefficient is just 1. So my factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's my constant. My lead coefficient, the factors of 1 are just plus or minus 1. So when I do this division, it's going to be really easy because 1 divided by 1 is 1. 2 divided by 2 is 2. 3 divided by 3, 3. 3 divided by 1, 3. And 6 divided by 1, 6. So your answer here is just plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's your entire answer for this problem. For number 4, it asks you if a polynomial with rational coefficients has the roots 2 plus radical 7 and 4 minus radical 3. So it gives you 2 roots. Find 2 additional roots. That's the important part. That's what we need to figure out. That's what they're asking us to do. Find 2 additional roots. So what we have to think about here is the buddy system. The technical terminology for the buddy system is the conjugate root theorem. So if you see conjugate root theorem, think buddy system. Does 2 plus radical 7 have a buddy? Yes, because any radical must have a positive and a negative value associated with it. So I know that if 2 plus radical 7 is a root, then 2 minus radical 7 is also a root. Same thing with 4 minus radical 3. The radical 3 means I have to use the buddy system. I have to consider the positive and the negative value. So I also have 4 plus radical 3. These are your 2 additional roots. In problem 5, they're asking you to do the same thing, except it says find 1 additional root. The reason you can only find 1 here is because if you look at 2/5, that's a fraction. It is not a radical, and it is not a complex number. So I'm looking for 2 things, either a radical or an I. Those 2 things follow the buddy system. If it's not either of those 2 things, it does not follow the buddy system. So if they are looking for 1 additional root, 2/5 means nothing to me. It's just this 3 plus radical 11, and we know that that means we also must have 3 minus radical 11. So that is your 1 answer there. This next question, again, is very similar to the 2 we just did. It's saying if you have this polynomial and they give you these 2 roots, what do you know to definitely be another root of this polynomial? So basically, identify another root. Well, do you see anything that has to follow the buddy system? Does 1 have to follow the buddy system? No, because it's not a radical and it's not a complex number. It doesn't have I. But this has a radical in it. This is a number that must follow the buddy system. So if 4 plus radical 15 is a root, then 4 minus radical 15 must also be a root. This next problem is really similar, except it does make you think a little bit more. It says a polynomial with real coefficients 4, radical 5, 2 minus 4i, and I plus 3 as 4 of its zeros. So that's 4 of the answers it's saying. But it wants to know what is the least possible degree of the polynomial. Remember, the degree is going to be equal to the number of answers. Now, we don't know for sure how many answers this has, but we do know it has at least 4 because they gave us 4. But we also know that it has to have a few more than that because some of these follow the buddy system. So if I look at 4, 4 does not follow the buddy system. So I know that 4 is an answer. I don't know anything else. But if I have radical 5, then I know I must also have negative radical 5. That must be another answer. It has to be there. 2 minus 4i. Again, I have to have 2 plus 4i. It has to be there. It has to be an answer. And for I plus 3, I must also have negative I plus 3. Be careful with that one. That's a little bit different than what we usually see. It's the thing in front of the I that is going to change. So this does not change to I minus 3. It changes to negative I plus 3. Either way, though, that's not the particular point of this problem. The point of this problem is it wants to know what is the least possible degree. So how many answers, at the minimum, does this problem have to have? Well, it has to have 4, because those are the 4 that it gave us. But then we know, using the buddy system, it must also have another 3. So the 4 they gave us, plus the 3 we know from the buddy system, says that this must have a degree of at least 7. Okay, so for this problem, it's saying to find the rational roots. When it says to find the rational roots, that means you need to go through the entire process. You need to find the possible roots, then use synthetic to find one that works, and then go through and factor, either by the beats or difference of squares, or by using the quadratic formula. So if we start going through this one, I know my possible roots are going to come from the factors of my constant divided by the factors of my lead coefficient. So I have factors of my constant are positive negative 1, positive negative 5. Factors of my lead coefficient, that's just a 1, so plus or minus 1. So my possible roots are plus or minus 1 and plus or minus 5. So I'm going to go ahead through and I am going to use synthetic. I'm going to pick negative 1. We'll see if I'm right. And I plug it in using the synthetic. See what I get. Negative 1, 4, negative 4, negative 3, 3. Okay, that doesn't work. I got 8, so that's no good. Negative 1 doesn't work. I'm going to try 5. 1, 5, 1, 5, 1, 5, 10. Oh boy. I know that's not going to work. I'm going to try negative 5. 1, 5, 1, 5, synthetic. Aha, I got it. So because this is a 0, I know that x equals negative 5 is a root. So success. I found one of my answers, but I need to keep going. So now what I know is when I take out that negative 5, I have these numbers telling me my remaining polynomial is x squared plus 1. But I don't know how to factor that because that's the sum of squares, and we haven't learned that. There isn't a special rule to it. What I have to do is the quadratic formula. So the quadratic formula you need to know for this test, it's opposite of b plus or minus square root b squared minus 4ac all over 2a. That's what x equals. So I'm going to go ahead and I'm going to plug in. And what's really convenient is when you get these 3 numbers down here at the bottom, that's your a, your b, your c value. They're already listed for you, a, b, c. So a is 1, b is 0, c is 1. And I'm going to plug those in. What I need to do, though, is I need to shrink this a little bit to give us some more space. So I'm going to plug that into the quadratic formula. I get x equals the opposite of b, so that's just negative 0, plus or minus square root b squared minus 4ac all over 2a. The first thing we're going to do is put this into our calculator. That's our discriminant. Our discriminant's really easy to calculate. We just put parentheses 0, parentheses squared, minus 4, parentheses 1, parentheses, parentheses 1, parentheses. When we put that into our calculator, we get 0 plus or minus the square root of negative 4 over 2. Well, if I have a negative underneath the radical, I know I have to take out an I. So I know it's going to be 0 plus or minus I radical 4 over 2. I also know that the square root of 4 is equal to the number 2, so 0 plus or minus. Instead of writing I2, we're going to write 2i, because we always put our letter at the back. Now, 0 plus 2i and 0 minus 2i, that 0 doesn't do anything, so I can just write 2i over 2. And then these cancel. Sorry, I forgot the plus or minus. And my answer is x equals plus or minus I. So here's 2 of my answers. We had x equals negative 5 being one of them as well. So if you look at your degree in the original problem was 3, and you did just find 3 answers. So those are your 3 answers for this problem. All right, so this problem, again, we want to go through and we want to find the roots. So if you're finding the roots, that means you're doing the whole process, the whole kit and caboodle. I'm going to find the factors of my constant, which are plus or minus 1 and plus or minus 2. Factors of my lead coefficient, plus or minus 1. When I do that division, 1 divided by 1 is 1, 2 divided by 1 is 2. So my possible roots are plus or minus 1 and plus or minus 2. So now I go through and I do synthetic. I'm going to pick 1. Pick 1, and I'll plug it in 1, 5, negative 4, negative 2. My 1 comes down, 6, 2. Ooh, good. I got it. My first try, I got it. X equals 1 is a root. So that's one of my answers. But I have to keep going. So what I'm going to do is I'm going to take my degree. I'm going to put my letters back in. So if I started with a degree of 3, I now have a degree of 2, degree of 1. So x squared plus 6x plus 2. I could try to factor that using the beats, but do we have any factors of 2 that can add to give me 6? No, that's not going to happen. So instead what I need to do is use quadratic formula. My a is 1, my b is 6, and my c is 2. So remember, you can always just use these 3 values here as your a, your b, your c. And I'm going to plug that into the quadratic formula. So opposite of b plus or minus square root b squared minus 4ac all over 2a. I'm going to put my discriminant into my calculator. Remember, that's this part right here. So I have 28 underneath my radical. So, oops, I get negative 6 plus or minus square root of 28 over 2. That gives me, 28. I'm going to enter square root of 28 into my calculator. You know, the ones in class will reduce this for you so you don't have to do Joe's method. If you don't have a calculator like the one we have in class at home, you need to do Joe's method on this 28. But the calculator will tell you it reduces to negative 6 plus or minus 2 radical 7 over 2. And then you can look at this and you can see that you've got this 6, this 2, this 2. Those are all going to simplify. Your answer becomes negative 3 plus or minus radical 7. Because these cancel all by 2. I get 3, 1, and 1. So these are my other 2 answers. That's 2 of my answers. X equals 1 was my third one. So those are my 3 answers for this problem. All right, let's go. We're going through it again. We're looking for all the zeros. So possible factors, I've got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over plus or minus 1. So all of my possible roots are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. I'm going to pick 8. That's a big number. I'm going to pick 2. So I'm going to plug 2 in, synthetic, 1, negative 5, 2, 8. Ooh, nice, I got it. So because I ended up with that remainder of 0, that means that x equals 2 is a root. And now we're going to go through. We're going to put our variables back in. So I get x squared and x squared minus 3x minus 4. Can I do the beats there? I think I can. Factors of -4 that will give me a -3. Factors of -4 that will give me a -3 are -4 and +1. So there, I did not even have to do the quadratic formula. Could you have done the quadratic formula? Of course you could. That'll always work. But you can also factor this, which makes it a lot easier because if x plus 1 is a factor, we know x must equal -1. And if x minus 4 is a factor, we know x must equal 4. The way we did that is by setting it equal to 0 and solving for x. Or x minus 4 equals 0. I add my 4, I add my 4. So that's the long way of doing it. But we got really good at doing that last chapter, and we figured out that we can just flip our sign. So here's two of our answers. X equals -1, x equals 4. And then our third one is the one that we found by going through and doing synthetic. And you can see by the degree that you only should have those 3 answers. So let's go on to the next problem. We're going to do the same thing again. Factors of my constant. That's just positive -1 and positive -13. There's no other factors. My lead coefficient is positive -1. So my possible roots are plus or minus 1 and plus or minus 13. So I'm going to go ahead through, I'm going to try 1. I'm going to see if 1 will work with synthetic. Oops, that should be a 2. That doesn't seem to work. Okay, so 1's not going to work. Let's try -1. There it is. -1 does work. I get my remainder of 0, so x equals -1 is a root. Now that we have to go ahead and we need to finish this problem. So I'm going to shrink up the page real quick because we need some more room. If I take these values here, the 1, the 0, the 13, I know right off the bat that that's not going to factor because I don't have a b value, which means this is my x squared and I have a positive 13. So I can't factor that. It's not the difference of squares. So I'm going to plug it into the quadratic formula. Get opposite of b plus or minus the square root, b squared minus 4ac all over 2a. And my discriminant, 13 times 4, I get -52 underneath my square root over 2. So the first thing I see is this negative, which means I need to take out an I. So I'm going to have -0 plus or minus I radical 52 over 2. And then 52, this square root of 52, I'm going to put in my calculator, and it's going to tell me that I end up with 0 plus or minus 2I radical 13. 2 radical 13 is what that radical 52 will simplify to, which gives me 2I radical 13, sorry, plus or minus, don't forget your plus or minus, it's really easy to lose, over 2. And these 2's will cancel, and you are left with plus or minus I radical 13. So these are 2 of your answers. Your other 1 answer came from x equals -1 working in that synthetic division. So there's your 3 answers for that problem. Okay, so we're getting into a different type of problem here. These, it's asking you what cubic polynomial equation has these 2 roots here. So it's looking for a polynomial. It has these 2 roots. we have to first think of the buddy system. So does negative 7 have a buddy? No. But does I have a buddy? Yes. You also have to have negative I. So now total I have 3 roots, which means I need to set up 3 sets of parentheses. I'm going to put my x plus 7, because I switch the sign when it goes into the parentheses, and then x plus I and x minus I. Now, I'm going to have to go through and I'm going to have to double distribute. But remember, it's always good to double distribute with your buddies first, because your buddies are going to lose those middle terms. They're going to cancel out. Every time you have the exact same thing with 1 plus 1 minus, your middle terms will cancel. So you only really have to multiply the first and the last things here. So I get x squared minus I squared. And I squared is equal to negative 1. So this is really x squared plus 1. And I still have to bring down that x plus 7. And I'm going to multiply that in now. So let's distribute x. I get x cubed plus x plus 7x squared plus 7. I don't have any like terms that I need to combine, but I do see that this is out of order, so I should put it back in order. And once I have it on order from high to low, that is my answer. I'm going to do the same thing with problem number 14. If I look at 3 does not follow the buddy system, but radical 7 does. And I know that radical 7 is going to also have a negative radical 7 with it. So that's 1, 2, 3 sets of parentheses that I need. I have x minus 3, because remember you switch the sign when you put it in there, and x plus radical 7, x minus radical 7. Again, I'm going to double distribute my buddies first. So x squared, I can skip my middle terms because I know they're going to cancel. And then radical 7 times radical 7, get negative radical 49. But I know that the square root of 49 is 7. So x squared minus 7. This set of parentheses comes down because I haven't dealt with that yet. And now we're going to double distribute. So I have, let's see, x times x squared is x cubed. X times negative 7 is negative 7x. Here I get negative 3x squared and plus 21. Again, these are out of order. So we need to put it from high to low, which means x cubed minus 3x squared minus 7x plus 21. And that's your final answer for that problem. So for our definitions, we're going to talk about how we use them in this class. And for the first one, rational root theorem, that's to find the possible roots. So we use the rational root theorem to find our possible roots by taking factors of our constant, dividing that by factors of our lead coefficient. That's the theorem that allows us to do that whole process. The conjugate root theorem is when we are looking at the buddy system. So what that tells us is we have our positive and negative for any complex or radical. So complex is when we have i's. So anytime you have an I or a radical, the conjugate root theorem tells you that the buddy system is in effect. You must have the positive and negative for any radical or complex number. One last thing with the conjugate root theorem is, let's say you have, let me do a quick example. Let's say you have I and radical 2. Those are two given roots. So you also know that negative I and negative radical 2 are roots. That means you have 4 different answers there. So what is the degree of the polynomial? Well, the degree has to be 4 because you have those 4 answers there. Now, it could maybe be more than 4 because there could be some other numbers like 2 or 5 that just aren't included in that. These are only considering the complex. But your degree is going to be equal to the number of your complex solutions. The fundamental theorem of algebra, this is where you go through and you find all solutions using synthetic and factoring. That's when you use the fundamental theorem of algebra. So it's bringing everything together, saying that when you have your possible solutions, you can use synthetic to find one, then you can factor to find the rest of them. Synthetic division is just that process of dividing a polynomial. And it's very, very helpful to us because it helps us find actual roots. So there's your review video. Please study, rewind this, rewatch parts. Your test is coming up. You need to make sure you're prepared for that. So let me know if you have any questions in class. I'll see you then.